got that breakfast thing. I think I'm in the bubble station, which is really cool. You saw that activity. I think it's an asset. Just so
That's what
situated, and I think we'll
So he knows the breakfast.
I don't know if there's going to be an influx here.
Like, what else can we do? Pull out and yes.
Yeah, we've got baseball
So I
practice.
told him.
Wednesday's a busy day. Church for some.
It's Wednesday.
Wednesday church thing for some.
Or someone said Philip Square.
Just a little. That's the game. Rocket or sneakers. That's it. The main attraction. So that's it, y'all.
He's supposed to come today.
Bring the hops.
But I won't sit in front of you because I'm tall.
Also, you have the only.
Where's the snacks?
Crack open.
I like them both. I didn't want to spill. I don't like it.
I was gonna say that's a polite way to put it. I think we'll do introductions. Jump right in. We've got a video, and then we can do introductions, like talk about ourselves, so that we can come to ask some questions. Is that what it's on? Yeah. Whatever you guys want to do. Okay. We don't have to do it now. Yeah. Here's why we're doing just a talk. Start with some stuff that you can go and see. Hopefully for you. No. Just go for it. Yeah, there's no formality. Okay. You're sitting in the middle. Shall we cover?
Yeah, just press it down one time. Green, double green. That's not turned on.
Okay. For the sake of his sanity, get as cozy with the front of it.
Should be on that.
Gotcha.
Those should be on the
Test, test. Nope.
2, 3.
Test. 1, 2. I'm on TR2.
Try to talk. I guess it's that power button down. Turn it off and turn it back on again. Testing. Not sure. Green light.
Yep, have a green light.
I'm going too naturally, try to get
Testing.
There we go. Turn the volume.
Yay.
Thank you. Yeah, sure.
I'm not gonna share with Pete.
Oh, hey, everybody, how you doing?
Thanks for coming.
Before we do the full-on introductions, we have a little video to get it started. We're hoping that this could be more of a discussion panel, so hopefully you have some questions, and hopefully we can incite some questions. That goes a little slowly. We've got lots of rants we can go on, but the idea being we're going to talk about the eclipse that's coming up.
The sun is a star. It's a star that we often describe as average, run-of-the-mill, just ordinary. Yet this ordinary star is responsible for helping to sustain all life on Earth. No other star that we know of has that level of responsibility, and that's pretty extraordinary, if you ask me. The sun is a living, breathing star. It is active, dynamic, and ever-changing, just like us. Its influence can be felt in every aspect of society, from agriculture and economics to arts and culture, as well as the physical, mental, and emotional health of human beings. The sun touches everything. And to highlight the importance of our extraordinarily ordinary star, NASA is hosting the Heliophysics Big Year. Beginning with the annular solar eclipse in October of 2023, continuing with a total solar eclipse in April of 2024, and ending with Parker Solar Probe's closest approach to the sun in December of 2024. The Heliophysics Big Year is a global celebration of solar science and the sun's influence on everything. Over the course of the year, we are challenging everyone, including the public, the science community, and you, to participate in as many sun-related activities as possible. Heliophysics is the study of the sun and its influence on, well, everything. NASA has a fleet of strategically placed spacecraft that work alongside other missions from NASA and space agencies around the globe to monitor the sun 24/7. Together, we are working to increase our understanding of solar phenomena, such as solar flares, the solar wind, and space weather. We have missions studying everything from Earth's uppermost atmosphere, where the International Space Station lives, to our 45-year-old Voyager mission that is investigating the outer boundaries of our solar system. We've even had one mission that has actually entered the sun's atmosphere. Parker Solar Probe touched the sun. Studying these complex systems helps us better understand our universe, including our solar system, distant stars, exoplanets, and our search for life on other planets. Understanding the sun's activity is critical to all of NASA's endeavors, especially our human exploration efforts. It underpins our Artemis missions, enables us to protect technology on Earth and in space, helps safeguard our astronauts, and allows us to voyage to Mars and beyond. The Heliophysics Big Year is a unifying effort designed to encourage exploration, creativity, and wonder. We invite you to engage in the world around you with intention and curiosity. We invite you to experience the annular and total solar eclipses with us. We invite you to do science and to experience our sun in different ways. Throughout the year, there will be opportunities for communities across the globe to participate in sun-related activities such as experiencing solar eclipses and auroras, joining citizen science projects such as HARP and Spritacular, creating sun-inspired art, music, fashion, and food, and a host of other fun heliophysics activities. So please join us for the Heliophysics Big Year and help us celebrate our extraordinarily ordinary star.
So that was our boss, Nikki.
Who was also instrumental in the Parker Solar Probe.
So, sorry about that. I'm Adam Kowalski.
Oh, I'm Mitzi Adams.
I'm Pete Robertson.
We all work for the NASA Marshall Space Flight Center. We're here for the eclipse. So us working on the sun, it's natural that we would want to come here to talk about the science of an eclipse. Pete, also, his whole science is based on the impacts of the sun on our atmosphere. I'm sorry to simplify it as such.
Yes, it's as everybody knows, the sun's energy hitting the earth. That's the whole reason for our variations in weather, how our climate evolves, everything that is connected to motions of the atmosphere, the oceans. The first order comes from the sun. And so we're interested. We have our own fleet of satellites that look toward the earth, actually a measure of solar radiation coming in from the sun. And so this connection between our lives, what we experience in terms of meaningful weather and climate, derives first order from the sun.
And in 2017, Dr. Robertson was part of a group who went to Austin Peay State University in Clarksville, Tennessee. And he participated in a citizen science project known as Globe Observer and took temperature measurements during the solar eclipse, well, before it, and during, and then a little bit afterwards. And you're going to hear more about that shortly, I think.
Yeah, so the idea again is we're going to hopefully you have discussions, things you want to know, because we can guide it wherever we want it. But that might not be what you guys want to hear about the eclipse of the sun. So we've got hours of slides prepared, and we're not going to go into them unless you ask. So some starter questions to think about, to ponder, that we let you know, to seed inquiries that you might have. We have up here, such as why does NASA study the sun? Reasonable thing. How can you safely observe an annular eclipse?
Or a total eclipse.
What kinds of data might actually be available and out there afterwards? How can you be involved? What tools are available to make safe solar observing? And how and why do solar eclipses occur? Put our names up there so you can direct them towards us and our knowledge base as we go along. But to start with, does anyone have any direct questions already about the eclipse? Yes, please.
You might have already answered this. Does it just get dark? Like, is it like midnight or?
No, it's not like midnight. It is sort of like a midnight with a little bit of sunlight shining around all the horizons. Sunlight all the way around, 360 degrees.
Because we had the other one, in October, and the sun looked like that. Dark with the ring around it.
Right.
But you're saying it's going to be dark on top but light around it?
Yes.
So this is, yeah, so you saw this over on the right.
Yeah.
And you'll see this, but then the horizons will be lit up as well.
it will be dark. It's sort of like, imagine that you're a giant and you're standing in space and you have a big bowl. And this giant has it in for you for some reason. And she decides to place that bowl right on top of where you're standing. Not on top of you, but directly above you. But she doesn't let go of it. She just takes it down until it's just above the horizon. So everything above where the bowl is going to be dark, but you'll still have a 360-degree sunrise sunset. And it'll last for about 4 minutes in our area, and then it'll very quickly get bright again.
So to partially explain, if you think about this, where you see you have the layout of the eclipse, where you have the sun, you've got the moon and the earth. And so what you're seeing during the eclipse is that the moon's shadow is falling on the earth. And so it's around the edges of it. Your neighboring towns still have a little bit of light. So all around you, you can kind of see some of that factoring in.
Let me give you my perspective from 2017, which was my first and only eclipse so far in Tennessee. And, you know, we knew that the moon was moving over the sun's disk, and it was getting dimmer and dimmer and dimmer. And it got just like twilight. And then all of a sudden, it was as if this shroud came from the west, and it turned dark, almost like midnight. But as Mitzi said, you know, all around the rim of the horizon, there was pinkish clouds, you know, the refraction of the sunlight. It was gorgeous. It was moving. You felt your relationship with the cosmos, but this veil of darkness that came all of a sudden. I assume it'll be like that here too.
It should be pretty pronounced in this location because it's so flat everywhere. If you can observe a total eclipse from a hill, often you can actually see the shadow approaching. And there are cases where you can see it approaching in a flat area like this at a very, very fast speed. So if you blink, you'll miss it.
Is that a long answer?
So my question is, not all areas will go dark?
As long as you're in the path of totality, it will be dark. If you're close to the edge of the path of totality, then outside that edge will be brighter. And if you look inward towards the middle of the path of totality, it'll be darker.
So like where we're coming from in Huntsville, it's only going to be 89% blocked. And as you get closer to this line, it will get closer to 100%. And when it gets 100%, that's where you get the darkness. And so that's what you can kind of see. It goes down from 100% here, down to get far enough away at 0%. It's just another day.
We're on the line, or we're in the margin.
We're in that path, yeah.
And actually, Garner State Park sits very, very close to the middle of that path of totality.
Now within the path, it's not, if you're on the line, it's not going to be like, oh, this looks better than a little off the line. It's going to be a little longer, as long as you're within the path of totality. Now, if you're a little outside of the path of totality, it goes from amazing to like, oh, that was kind of neat.
So the day before and the day after, no.
Nothing.
And there, in 2017, many of my friends, because it was about 99% total in Huntsville, and many of my friends said, well, that's good enough. And I said, no, it isn't. If you can travel, get into the path of totality. And all they had to do was drive north an hour. And I can't tell you the numbers of people who will go thousands of miles to get into the path of totality. And it is really, really incredible event. And as the eclipse progresses, it will get gradually darker and darker, but you really don't notice it very much until it's between 90 and 95%. And then and as it approaches 90%, you can tell there's a difference in the light, but it's not, it's kind of weird. If you happen, I had to change a tape once during an eclipse, and I went into the building to change the tape, came out of the building, and the change in illumination was dramatic because I've been away from it, but it's very gradual until you get to about 95%, and then it just goes really fast.
I had my great aunt who was born in 1900 took a cruise. I couldn't tell you where. You probably know, but this would have been in 1980s, probably, to go see a total eclipse.
Good for her.
So there's a good analogy between of the difference between almost total and total. So if you have 99% total, is that good enough? Well, think about walking into an ice cream shop and you see an ice cream cone sitting there and it's got ice cream on top. And you can't eat it. Think about the difference between seeing it, smelling it, and seeing it, smelling it, and tasting it. And that's the difference between 99% and 100%.
How long are you guys here in this area, and where will you be for the eclipse? In Garner State Park, maybe, or?
We are spending time between Garner State Park, here, Eagle Pass, and Del Rio, and I believe we will be in Eagle Pass for the eclipse, but there will be a group of us here. We're all kind of jumping around through the area to make sure we're supporting where we can.
Explain the time frame of Uvalde in the partial in October, and then share with us, does this path with the total come to the same community as it did this year, or does it always happen?
Carbondale, Illinois. In 2017, Carbondale experienced a total solar eclipse. In 2024, Carbondale is experiencing a total solar eclipse. And in October, this area experienced an annular, and now we're about to experience a total. That's very unusual. And Adam, when is the next total solar eclipse in the contiguous United States?
Funny you should ask. It's almost like we prepared slides, a lot of them. Just give me 20 minutes to get through the deck.
Oh my gosh. Whoa.
Don't wait.
So the next one after this, there will be one in the 30s that will hit a bit of Alaska. There'll be a few that go near Hawaii. The next one to hit the contiguous United States will be in 2044 in northeastern Montana, which is very difficult to get to. It's a really cool place, but it's real difficult to get to. We'll say 2045 is the next solar eclipse that goes through the continental United States. So if you miss this one, you gotta wait till 2045. Now,
Get your cruise package mailed in.
now this is normally, for the past year, we've been trying to, giving these eclipse talks, do these things, and everywhere else has been outside of the past. And the whole time, all of our practice has been trying to convince people to go. So it's a very nice change of pace to be like, yeah, and you're here. You don't have to go far. Just give it a shot.
So how do you determine when the next year and where?
Okay?
Thousands of years ago, people started writing down things that they observed in the sky. And they kept very careful records. and they noticed patterns in the things that they were writing down. And eventually, they were able to predict when another lunar eclipse could happen, when another solar eclipse could happen. They were not able to accurately determine where the path of totality would be until 20, 30 years ago. And that's because we now have computers that can very, very carefully and accurately calculate where that path is going to be. And a lot of this is based on, we stand on the shoulders of giants. So, people started writing things down. We had individuals who developed physics of motion and the motion of our Earth around the sun, all the planets around the sun. And all of those calculations go into predicting when and where the next one's going to be. And there are similarities between eclipses. And there is a cycle of eclipses called the Saros cycle, which is really complicated, but basically it means that you have an eclipse that happens today, and in some period of time, you're going to have an eclipse that is similar in extent and location to one that happened previously. So
I do have slides on that, but it's in a different slide deck.
But the previous slide that Adam had up, that path of totality is similar. It's not identical, but it is similar to the path of totality from 2017.
When was the first recorded total solar?
Oh, I don't know.
They were, as far as we can generally go back, there's probably a time where they weren't predicted, so I'm not, we've been able to predict eclipses since we basically have
like
written
an official
records.
recording of like this is a total
Right.
solar eclipse.
I think the Chinese made the first recording of a total solar eclipse. And I think it was probably around 5,000 years ago.
And shortly after that, they were predicted.
So
Yeah, it's been neat.
why does an eclipse happen?
Yeah.
Good segue.
So the eclipse happens because the moon orbits around the Earth, right? The Earth orbits around the sun. Anytime they're directly in line with each other, we have an eclipse. Whenever those three bodies, if it's sun, Earth, moon, that's a lunar eclipse. If it's sun, moon, Earth, that's a solar eclipse. And so the next thing is like, okay, we've probably heard about lunar eclipses happening pretty frequently. Well, that's because if you look the relative size of the moon to the Earth, it's one way, but the relative size of the Earth to the moon is much bigger. So that's one reason. And then the next reason is, we go to my awesome graphic. I know it's cheesy, but I'm still proud because I made it okay. This is from the actual data that you can get from the JPL ephemeris. And so what they're doing is they've mapped out where all these planetary bodies will be. And so you can see, okay, it's orbiting around about once a month. Every new moon, they're almost in line, right? Where the moon is between the Earth and the sun. But it turns out it's not flat. And so if you want an eclipse, you need to have the moon right between. But just to have a new moon every month, the moon can be up here or the moon can be down here. And that's another cycle. So you have the cycle of the orbit, about 28 days. You have the cycle of going up and down, which is about 27 days. And so they just don't quite line up. When they line up, you get the perfect eclipse where it's right at the right height.
Should we do kinesthetic astronomy?
That's up to you.
All right.
I've been standing all day, I'll sit.
I think this is really useful to do. So I need 2 volunteers. Okay? Oh, perfect.
Oh, great.
And I said perfect because you're wearing blue. So you get to be Earth.
Okay.
And you are very bright, so you're going to get to be the sun. And I would like for you to walk this way with me. And we're going to put you way over here. Okay, stop about there. Okay. And I would like for you to walk forward maybe 5 paces. Okay. So, I'm the moon. I can't see the sun. And so the sun is shining on Earth, and there's a shadow cast. And I'm completely in that shadow. So that is a lunar eclipse. Well, I am orbiting around Earth. And now I am standing in the middle between sun and Earth. And now the moon's shadow, is shining, The moon shadow is falling on Earth. So that is a solar eclipse. But because the moon is very small, that shadow is also very small. Now, if I'm down here, you don't have a total solar eclipse. You can have a partial eclipse. And sometimes I'm up here and you'll have a partial solar eclipse. It's only when I'm exactly in line with the sun that we have a total solar eclipse. Thank you, volunteers.
Good work. How come sometimes you get the eclipse like you had in October where it's not fully blocked out?
You had to ask after I sat down. Well, the moon is not always at the same distance from Earth. Sometimes it's a little closer, sometimes it's a little farther away. And if you move away from an object, it looks smaller and smaller. So when you have an annular eclipse, the moon is close to or at its farthest point away from Earth. So it looks smaller. And then it does not completely cover up the sun. And you get the annulus or ring. I like to show off my Latin. And you get a ring of light around the edges of the moon. And you have an annular, not annual, but an annular eclipse. And we called it a ring of fire. And it does kind of look like that.
How far away is it, the moon?
It's roughly 250,000 miles. And it's plus and minus that.
How did it affect, like wildlife and?
Ooh, good question. I think this is a peak question.
Somewhat.
Well, yeah, in 2017, from what we could tell, the birds went absolutely crazy when the total eclipse finally materialized. And they were flying overhead disoriented, as I remember. And of course, I don't recall what kind of birds they were, but they were not big birds. There were turtles which had been sitting on a log, and I think they disappeared into the water. I don't know why. The cows had already been sitting under the trees because it was hot that day, and they just stayed where they were. So we didn't see much reaction of the cows. But I'm not an expert on that, but I know that the various animals and insects all react in strange ways, perhaps unpredictable, but in some ways predictable. So that will be an interesting thing to see around here if we have the opportunity.
In 2017, we were at Austin Peay State University's farm. They have a working farm, and they also have an astronomy observatory there. But we took a group of students, actually several groups of students, to participate in the eclipse. And one of the things the students got to do was paint cows. There were 10 cows that were selected for this experiment. And so the students painted non-toxic paint onto the cows one by one. And then on eclipse day, the cows were let go out into the field, and they then went right to the tree and lay down in the shade. During totality, which was only about 2 minutes, a little over 2 minutes, one of the cows came out from under the shade tree. Only one. But that's a lot of inertia in a short period of time. We also had the head of the agriculture department, Dr. Don Sudbrake, had a collection of crickets, and he had some students observing the reaction of the crickets. And they did exactly what you would expect. They started to chirp as soon as it got dark. And in another location, one of the beekeepers from the college was watching the bees. And almost all of the bees returned to their nest during totality. And after totality ended, they took a while before they started to leave again, because they were a little bit freaked out by the fact that it got dark in the middle of the day. And it cooled down considerably. Another thing that we noticed, one of the students happened to be kind of a grower of plants, and he noticed that one of the plants, a melon variety, closed up. And what happens with these is they open up during the morning, and they stay open all day until it gets dark, and then they close up. And if they're pollinated during that time, they'll produce fruit. Well, once they close up, they die and they fall off. Well, unfortunately for these melons, they were only open for half a day. So if they had not been pollinated during that time, then they would not have produced any fruit following the eclipse. I'm trying to think if there was anything else to be.
The roosters are gonna go nuts.
Pardon?
The roosters are gonna
Yeah.
go crazy.
Yep,
Yes,
that does. Yeah.
yes. I don't recall any chickens around us, so I can't report on that.
I was in Oregon, I can attest to that.
I have another two-part question. So what is NASA studying, or what are the two studies that they're going to do on Monday? And two, are you familiar with Arizona State's balloon release, and can you explain that one, or maybe Professor Morales can?
What are the two experiments? There are more than that.
Well, at least two, or
Oh, at least two. Okay.
what do you want to see? Or what do you want to prove? What are you looking for?
One of the citizen science experiments is called Sun Sketcher, and you too can get involved. It requires you to download an app onto your phone, and then dedicate your phone to taking pictures of the sun, moon, during totality. You start the app a few minutes before totality. You point the phone's camera at the sun, and let the app run. A few minutes after totality, you move the phone, turn off the app, upload the images. So that's Sun Sketcher. And the purpose of that one is to determine the shape of the sun. We know more or less that the sun is shaped as a sphere, but we don't know specifics. And knowing a lot more accurately what the sun's shape really is will help us understand what's going on underneath the surface that we can see. So that's one thing. Another thing is Citizen Globe or Globe Observer or Globe Eclipse. And I'm going to let Pete take over with Globe Eclipse, and he can talk about the 2017 results and what is done with balloon launches.
Well, Globe is, as you can see there.
You're on.
Okay, Globe is a multinational program, international program. And one of its main aims is to increase environmental awareness. Another one is to contribute to scientific understanding of Earth. And the main one is supporting improved student achievement in science and mathematics. And so it's trying to get people who are interested in science into a way in which they can contribute to making measurements and sharing those measurements and actually working with them. And so at this point, there is a app, the Globe Observer. And for this particular event, there's a Globe Eclipse. They call it a Globe Eclipse Challenge. And I don't know if we can, is that hypertext work there?
I don't have anything.
Okay. So there's a whole protocol of how one might go about taking measurements of clouds. Looking at the sky, you can get cloud charts and you can see which types of clouds are present, and you can monitor them throughout the eclipse process, making observations and writing those down and entering those into this app and uploading those eventually. You can do also measurements of temperature, and they give you a specific protocol for that. So there are ways in which one can be involved in collecting these measurements from all these different locations. And here, this would be a very important observation to make and contribute those back to the community at large, which then can bring all of these data together and share them and use them for science studies. Let's see, I'm not too familiar with what the balloon project at Arizona.
Yeah, it's actually part of the Montana State Balloon Project. And there are multiple sites all across the nation that are going to be launching balloons with various types of payloads, but some of them will be weather related.
Mm-hmm.
And so, what would you launch on a weather balloon?
Well, weather balloons, actually they measure temperature, pressure, atmospheric humidity, and then by tracking the balloons and where they move and how fast they move, one can get an idea of the wind speeds. And so those are basic variables that one wants to know about. Balloon launches that the National Weather Service makes go up twice a day, at a number of locations all over the world, and all over the U.S., and then contribute to global measurements too. So during the eclipse, one might want to know, well, how, in certain ways, how does especially the lower atmosphere, which is in contact with the surface, how does its temperature, the winds change, pressure, and things like that. So those balloon measurements give us an idea of, I guess, what we would call the thermodynamic state of the Earth atmosphere and how it is changing during that period. And so those measurements are useful to have. We also have, a whole host of satellites which are looking down and probing the atmosphere, making measurements in profiles, taking those same sorts of measurements. So those will also be used. Yeah, let's go to that picture of that one right there. Here's a good example. This was taken in 2017 at the site at Austin Peay University. And this is a measure of how temperature varied during the eclipse. So here we are in the mid-morning. So we got time running this way and how hot the atmosphere was. We were making these measurements, about 6 feet off the ground like that. And so you can see the temperature start to rise. but it doesn't rise uniformly. There must have been maybe some cloudiness that kind of capped things off for a while, but then it began to rise again, but not as rapidly as before. And then it turned over as the moon moved in front of the sun, and it started to come down, and rather sharply too. You can see here we reached a minimum, and it was actually a drop of about 9.2 degrees Celsius. So that's something like 16, 17 degrees Fahrenheit. So there was a substantial temperature drop at the surface. And that all had to do with, the sun's radiation was hitting the surface and heating the surface, and then that amount of radiation decreased as the moon moved over the sun, and the surface started to cool off, and the atmosphere next to it also felt the surface, and it cooled too. And so these kinds of measurements give us a real interesting experiment. It's like having a day that's only about 3 hours long. So it's interesting to compare these rates of change. And, if we have more substantial measurements of humidity, the nature of the solar radiation, measuring in different wavelengths, papers have been published on this. And so it adds to our knowledge of exactly how these processes of the sun hitting the surface, whether it be vegetated or dry or concrete, how it reacts to changes in radiation.
Kat, did you have anything else you wanted to add about the balloon program?
Just that Arizona State, which is part of the National Balloon Eclipse Project, is going to be coming to our area and launch balloons from our area. One site, I believe, in Lakey, Polyutopia, and Campwood. And the PI there, the scientist will be here taking observations of the balloons here on Monday at our softball field.
What are the balloons? Like you'll.
Will we able to see them in the sky?
Yes. If they're like the weather balloons, depending upon what they're adding as a package that the balloon carries, those balloons weigh about 600 grams, I think. They're roughly as big as a car when you inflate them and let them go. As they go up, the atmosphere is thinner, they start to expand and cool off. If they reach their maximum altitude, they probably get half as big as this room before they pop. It would be about 15 miles up, so I don't know.
All the eclipse glasses and when you're supposed to wear them and when you're not supposed to wear them, the whole time, or when you can take them off, that sort of thing.
The rule is during the partial phases, the solar viewing glasses stay on if you look at the sun. During totality, you can take off the viewing glasses, but only during totality. And you have to be aware of when totality is going to end. There are apps that you can download on your phone that will actually do the timing for you so you don't forget. And they'll warn you when it's just a few seconds before totality ends, and warn you to stop looking at where the sun is about to get bright again, because you don't want to be looking at it when totality ends. So partial phases, glasses on; totality, glasses off; partial phases on the other side of totality, glasses back on. Now that doesn't mean you have to stand there for 3 hours with your eclipse glasses on.
Does it matter where, like this path of totality, Texas versus another state, is it the same? Or is the viewing different here in Texas versus somewhere else in the path of totality?
It'll be somewhat different because as you go farther northeast, the duration of totality will shorten. But the totality itself will look more or less the same. And the closer you are to the center line, the more symmetric everything will be.
And so for reference, down here, we're at like 4.5 minutes. If one were to go up, say, over to over here into Canada, New Brunswick, you're getting into like 3.5 minutes, 3 minutes, 10 seconds down to 3 minutes. So over in St. John's, well, St. John's will get anything, but over on that part of Canada, you'll get down 3 minutes, and then that'll slowly work its way down to 0 as you go further, right? So 0% this way, and then you're late, you go from totality down to 0% as you go away from the line, and then as you go along the line, you have that peak point, and then it goes down to 0 on either side of it.
So I understand we're about, I think the speed of the moon is about 1,900 miles in our area, almost 2,000 miles, and that increases, as I understand it, as you go northeast, or does that stay static as far as speed?
I don't remember, but that sounds good enough.
Its orbital velocity is about 2,000 miles an hour.
So is that why we have longer totality than they do?
It has to do with where the shadow is in relation to the land mass underneath it and the Earth rotating.
About how wide is the path? Like, is it miles? Is it less than a mile?
Oh, it is miles, and it can vary from eclipse to eclipse, roughly 150 miles. It's not very wide at all. And remember, if you see a lunar eclipse, anyone who is on the night side of Earth when there's a lunar eclipse will see an eclipse. But for a solar eclipse, that path is so narrow that you have to be in a very, very narrow area. And we could have eclipses every 18 months or so. But having an eclipse in the same location is very rare. And think about the Earth. Most of Earth is covered with water. So most often, that path of totality is going to fall on water.
Hence people taking cruises to see them.
So how does that affect like marine wildlife? If it does at all? The eclipse?
I don't know.
I think you should set up that experiment, propose it, and then go watch an eclipse from a cruise ship and study the wildlife. I would like to join.
I'm scared of it.
Amy, you're buying.
So are we in a full moon cycle then?
New moon.
New moon.
Yep.
So the tides are at their biggest or smallest?
It depends on the distance of the moon from Earth.
So will you all briefly discuss the phenomenon better known as Bailey's beads and the diamond ring? Kind of talk about that right before the total.
Yeah, but this is your wheelhouse. You are one of the examples who has traveled thousands of miles to see an eclipse.
So as the moon begins to move over the sun, the first thing you see is something that looks like a little bite. And there are legends in many, many areas of Earth that say an animal is eating the sun. So it does kind of look like somebody's taken a bite out of the edge of the sun when the partial phase begins. And then the moon, of course, continues to move, and so it moves farther and farther and farther over the disk. And just before it completely covers the disk, the edges of the moon become more pronounced. And you see light shining through the valleys on the moon, on the edges, which have been very accurately mapped. And so that looks a lot like little beads of light. And eventually, they just kind of all coalesce into one sliver of light, and then it's gone. And then as the eclipse ends, the moon begins to uncover the sun, and you get a flash of light. And this can happen on the other side too, as the moon begins to cover and totally covers. But you get a flash of light, which is the diamond ring effect. So Bailey's beads are little beads of light that are shining through the valleys and around the mountains on the edge of the moon. And everything kind of coalesces into one big or one narrow sliver of light that coalesces eventually into just one burst, which is the diamond ring. And it does kind of look like a diamond ring.
Well, this is not a very scientific question. It does relate to the eclipse. One of the big questions we get for our community is, how many people are you expecting? And it could be 1,500. We've heard 1,500 to 150,000. So, as someone who has traveled thousands of miles to see an eclipse, what would you expect in our community travel-wise to be seen? I don't know what else to ask.
This is a question that we've bantered about as we tried to prepare for this eclipse. And it is very hard to predict because so much depends on your location, so much depends on time of year. But I do know that the hotels in this area, in Uvalde anyway, have been sold out for at least 2 days. And actually, one of my colleagues had a reservation. I mean, eclipse, the day before the eclipse and eclipse day. And one of my colleagues had reservations from, I believe, today or tomorrow, through the 9th. And the hotel canceled his reservations for the 7th and 8th because they could sell the room for more money. And that happens. It actually happened to a professional meeting that we had in 2017. The Solar Physics Division had a contract with a hotel to host our meeting. And they broke the contract because they could sell our rooms for more money.
Can you tell us who the hotel is?
I don't remember. Adam may remember even where it is, but Jackson, was it Jackson Hole?
I believe so, yeah.
Okay, so somewhere in Jackson.
Oh, no, I thought the hotel here.
Oh, the hotel here. No, I don't know.
Although Mitzi, looking for reservations for this trip.
Pete, you have to hold it up to your mouth.
Okay. Mitzi found a hotel room for $1,000 night. Yeah, that was an Eagle Pass. We didn't take it.
So my mom believes in old wives' tales, and she's telling every female who's 3 months pregnant, do not be outside in those 4 minutes. How scientifically correct is she?
There's something about safety pins as well, if I remember right, that we discussed during the annular eclipse.
I was gonna say it's about as scientific as the chanclas for rain.
There you go. There you go.
I really think that a lot of what we call old wives' tales originated in real events where people would be amazed and frightened by the fact that it was getting dark in the middle of the day. And they would look up towards that hole in the sky and then look too long and then be blinded by the sun reappearing. And so that led people to say, well, you shouldn't go out and look at it at all. You shouldn't be in it at all because something bad will happen, because something bad did happen. But we don't really think that there's much of an issue with a pregnant woman viewing a total solar eclipse. I have a couple of friends who have been out in the light or lack of light during a total solar eclipse, and they didn't have any problems. But then again, you know, that's hearsay evidence. I don't have the actual numbers.
So those protect you by the glasses protect you because they block almost all of the light. So the sun is just very, very bright. It has so much that's hitting, and so it can damage it by just how much light it is. And so how those work is by blocking almost all of it. So you'll see nothing else, and then just barely you'll see the sun through them. You can test it, right? If you put them on here, you'll see that you can't see anything else in the room. Sometimes you'll look at an incandescent lamp and you can see the heating element from an incandescent lamp, generally speaking. So it's really only the very, very brightest things that actually make it through.
So when I was a kid living in San Antonio, I remember we went through I don't know if it was a total eclipse or an angular eclipse, but so they did an experiment or a project where you can see had something to do with like a cardboard, and then they poke a hole, and then so you could be able to see the actual, I don't know, is that still a thing, or was my teacher just messing with us? I don't know.
I was at that same junior high you were at.
Come on, Adam.
I told you. See, aren't you glad I'm not making you sit through all of these slides? Unrehearsed.
So there's something called a pinhole projector.
Yeah, it was something.
And a lot of people call it a pinhole camera. It's not really a camera unless you put a camera on it. But you can take a picture of the sun using a pinhole in a box. And you really want to make it a big box that's very long, which will give you a bit bigger image. But you can view it as well. It's just a pinhole projector. So if you make a hole in a piece of cardboard or a shoebox, put a pinhole in one end of the shoebox and a white piece of paper in the other end, and then point the hole towards the sun. Do not look through the hole. What you want is for the sunlight to shine through that hole and fall onto the piece of paper that you've put at the other end of the box, like a screen. And there are three-dimensional little models, little pinhole projectors that you could print if you have a 3D printer. And the plans are on the NASA website, of course. And you would just Google NASA 3D printing or 3D models, and you'll get a boatload of different types of models that you could 3D print, including the pinhole projectors. And what you'll see during the partial phases is you'll see little crescents on the ground. So you take this pinhole projector, the cardboard, or your fancy little one that you've 3D printed, hold it out, let the sunlight fall through it, and you'll see a little crescent on the ground during the partial phases. During totality, you won't see nothing because all the light's gone.
Right.
And if you don't want to do a 3D printer, take a colander, right? That's a bunch of holes. Those are actually about the right size. And so this picture on the left, that's just us looking at the 2017 eclipse with our colander. In the middle is my wife's straw hat. And you can see that all the little gaps in the straw hat made little pinholes that we just projected onto the ground. So there's lots of options. It's really cool what you can do with it. And like those are really great at giving a really good form. You can take a picture of that and it's really predictable. These are a little less predictable, but they're, I like the low budget solution sometimes.
So is that similar to, I know when we had it here in 2017, I think it was 2017. So the light that was shining through the trees.
Yes.
Yeah,
Leaves,
that's what
I was about to say that.
It was
Any
just like-
aperture.
Yeah, it was just a
just crescents
Pattern,
everywhere. Yeah,
Mhm.
yeah. If you have the right kind of tree, because out at Garner for the annular eclipse, the tree leaves were not, they just weren't, they didn't work.
Yeah. I guess it was oak, because that's what we have around here,
Oaks
so,
work really well.
yeah.
Yeah, that'd be really neat. That's one of those really creepy things that you get to check out. during
So
the-
will that also happen with the total eclipse?
Yeah, just not during totality. So this
Right.
is all lead up. Yep.
And then after?
Mhm.
the total?
Before totality and after totality. And you can also interleave your fingers and let the sunlight shine through your fingers. That's really cheap. Let's see, it is 8:08. Now, we're happy to sit here and answer as many questions or talk to you as long as you would like. But I did want to give you the opportunity to pull out if you want, or ask us more questions.
Missy, will you let everybody know about Saturday's event that you have scheduled for Briscoe Building and then the softball field?
I'm not sure I can remember the times. Let's see. So roughly
10:30.
10:30 to noon-ish. Over at
Library.
Saturday, right. So we're actually going to be at the library from 10 or 10:30 until noon. That is myself and one of our planetary astronomers, planetary scientists, Paul Bremner. And then Adam and Pete and possibly a couple other people from our TOPS Transform to Open Science program will be here. And that will be from 10 to 2?
10 to 12:30.
10 to 12:30, and then 2 to 5, observing out in the softball field.
If there, like, Saturday's the library and information session, kind of like this. But then-
Correct.
And then all day at the softball field on Monday, you just.
Right, all day on Monday, or,
And we'll also be at the softball fields on Saturday just to observe the sun. We have solar telescopes that we can use to stare at the sun.
What time at the softball field?
2 to 5.
and actually, I brought one of the little telescopes that we can use. This is one of the safest ways to observe the sun. It's called a sun spotter. And what you do is you unlock it, but it's like a pinhole projector. It's got a little pinhole, and it shines through onto a mirror, which is bounced back up to another one and through a lens, and you adjust it. You turn this, move this thing up and down, and turn it until you get the sun, until you get an image of the sun on this piece of paper. And it's really easy to use, and I like it. But the only drawback to a sun spotter like this is you have to continually adjust it because the earth turns. And so that image continually moves off the paper. But it's an extremely safe way to view the sun. And we'll have it out here on Saturday.
You had a question?
Actually, yes, I was gonna say that.
Okay.
Another interesting thing that's happening on Monday is Sarah's birthday.
Oh, happy birthday!
Happy birthday. Sharing the eclipse. She didn't know I was gonna say that. She's really excited that her birthday falls on the same.
That's good. We'll make sure if we see it, sing you happy birthday in front of everybody as loud as we can.
Well, do we have any closing remarks?
I really appreciate you all coming out. Like, this was great. I really enjoyed this. Hopefully this was useful for you and entertaining. Thank you all very much. Good. I'm Adam, this is Mitzi and Pete, and we'll be in the area until Monday. Say hi if you see us.
We'll be here until Tuesday. In the area until Tuesday. Going home Tuesday. Another long drive. But thanks for your attention and good luck to all of us. I hope we have clear skies.
If we don't, if we don't.
What time does it start and end?
You'd have to ask.
12:32 or something.